We are revising atoms and molecules. Theory of matter. Indian philosopher Maharishi Kanath postulated that if we go on dividing matter, we shall get smaller and smaller particles. Ultimately, a time will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. Another Indian philosopher, Pakuda Katyayam, elaborated the above doctrine and said that these particles normally exist in a combined form which gives us various forms of matter. Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these indivisible particles atoms. Laws of chemical combination. Laws of chemical combination were established by Antoine L. Lavoisier and Joseph L. Proust. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Law of constant proportions. In a chemical substance, the elements are always present in definite proportions by mass. Verifying law of conservation of mass. Considering the given reaction where sodium carbonate and ethanoic acid react with each other, giving us sodium ethanoate, carbon dioxide, and water. The respective masses of reactants and products obtained are sodium carbonate 5.3 gram, ethanoic acid 6 gram, and the products are carbon dioxide 2.2 gram, water 0.9 gram, and sodium ethanoate 8.2 gram. If we calculate total mass of reactants, it comes out to be 5.3 plus 6, that is 11.3 gram. And if we calculate total mass of products obtained, it comes out to be 8.2 plus 2.2 plus 0.9, that is 11.3 gram. Since total mass of reactants is equal to total mass of products, the law of conservation of mass is verified. Dalton's atomic theory. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates that he put forth are: all matter is made of very tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. Postulate number, or Dalton's second postulate, is based on law of conservation of mass, whereas Dalton's sixth postulate is based on law of constant proportions. Atom and more about atoms. So atoms are building blocks of matter. Atomic radius is measured in nanometer. 1 meter is equal to 10 raised to 9 nanometer, whereas 1 nanometer is equal to 10 raised to minus 9 meter. Berzelius suggested that the symbols of elements be made from 1 or 2 letters of the name of the element. Many of the symbols are the first 1 or 2 letters of the element's name in English. The first letter of a symbol is always written as a capital letter and the second letter as a small letter. For example, carbon is denoted by capital C, whereas cobalt is denoted by capital C, small o, so CO. Some of the symbols are derived from Greek, German, or Latin names. The examples are sodium The symbol is Na, derived from natrium. Potassium symbol is K, derived from calcium. Iron symbol is Fe, derived from ferrum. Copper symbol is Cu, derived from cuprum. Atomic mass. Since determining the mass of an individual atom was a relatively difficult task, relative atomic masses were determined using the laws of chemical combinations and the compounds formed. Unit of atomic mass is U, that is unified mass. Carbon-12 isotope is chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. Atoms of most elements are not able to exist independently, but they form molecules and ions. Molecules. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. The molecules of an element are constituted by the same type of atoms. The number of atoms constituting a molecule is known as its atomicity. So the atomicity can be monoatomic, diatomic, tetraatomic, and polyatomic. Argon and helium are the elements exhibiting monoatomic atomicity. Hydrogen and oxygen are diatomic. Phosphorus is tetraatomic and sulfur is polyatomic. Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. Finding ratio of combining elements by mass. The example under consideration is water, whose chemical formula is H2O. Here the combining elements are hydrogen and oxygen. So to find ratio by mass, we find the ratio of total mass of hydrogen to total mass of oxygen. Total mass of hydrogen is mass of one hydrogen atom multiplied by number of hydrogen atoms present in water upon total mass of oxygen is mass of one oxygen atom multiplied by number of oxygen atoms present in water. So mass of hydrogen, one hydrogen atom is 1. So 1 multiplied by 2 upon mass of one oxygen atom is 16. So 16 into 1. So we get 2 upon 16, which gets reduced to 1 upon 8. So ratio by mass or ratio of hydrogen to oxygen by mass in water is 1:8. Ions. An ion is a charged particle. It can be either negatively or positively charged. A negatively charged ion is called an anion. A positively charged ion is called a cation. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. A group of atoms carrying a charge is known as polyatomic ion. In case of an ionic compound, the constituent particles are positively and negatively charged ions. For example, sodium chloride is an ionic compound composed of Na+ and Cl- ions.